In this video, we're going to solve a problem which appeared in JEE Advanced 2015. Now, in this particular problem, it's given that we have a set S and it's a set of all non-zero real numbers alpha such that the quadratic equation alpha x square minus x plus alpha equal to 0 has two distinct real roots, x1 and x2. But here, they should satisfy the inequality x1 minus x2 mod is less than 1. Now we have to find out which interval is the subset of the given set S. Let's go ahead and solve the problem. Here, x1 and x2 are the roots of a quadratic equation. So we can easily identify the sum of the roots as 1 by alpha and the product of the roots as 1, right? Now, we have to find out that what is the value of mod of x1 minus x2. To find out that x1 minus x2, we square both sides, right? So therefore, we find out that x1 plus x2 whole square is equal to 1 by alpha square. x1 plus x2 whole square can be rewritten as x1 minus x2 whole square plus 4x1 x2. And now x1 x2 is equal to 1. So therefore, x1 minus x2 whole square will be 1 by alpha square minus 4. Now, it is given that mod of x1 minus x2 is less than minus 1. Therefore, x1 minus x2 is lies between minus 1 to plus 1. And hence, x1 minus x2 whole square is lies between 0 to 1. So therefore, we can say that mod 1 by a square and minus 4 is lies between 0 to 1. If we add 4 both sides, we get that 4 less than 4 less than 1 by a square less than 5, right? That's it. So therefore, if I reciprocate it, right, that a square, it lies between 1 by 5 to 1 by 4. Why? Because say that if 1 by a square is less than 5, therefore a square is greater than 1 by 5. 4 less than 1 by a square, which imply that a square is less than 1 by 4. Because when I reciprocate it, the sign of greater than converts to less than converts to greater than. That's it. Let's go ahead. So we obtain that a square is lies between 1 by 5 to 1 by 4, right? That's it. Now we consider that 1 by 5 is less than a square. Now as 1 by 5 is less than a square, the second condition, it's implied that a square is greater than 1 by 5. And therefore, when a square is greater than 1 by 5, it is only possible if a is less than minus 1 by root 5 and a is greater than 1 by 5. And that's why if we consider a number line and mark the point minus 1 by root 5 and plus 1 by root 5, right? And then we can easily say that, right? We can easily say that the required region or the shaded region represent the region where a square is greater than 1 by 5. Now we take a square is less than 1 by 4. So when we take a square is less than 1 by 4, it's imply that, right, a lies between plus minus 1 by root 2. So here we mark that minus 1 by root 2 and minus 1 by 2 and plus 1 by 2. Now notice that minus 1 by 2 is and plus 1 by 2, right? It's actually little greater than, right, that 1 by root 5, right, in absolute sense, right? So therefore, our alpha lies inside that interval, right, in the yellow shaded portion. Now, therefore, the alpha should satisfy both the region. So, therefore, it will be the intersection of these two regions. So, what will be the intersection of this region? That's only the shaded portion. So, therefore, we can say that our alpha should belongs to in a open interval minus up to minus 1 by root 5 union plus 1 by root 5 to 1 by 2. Therefore, we can say that these two are the subinterval of S or the subset of S. So therefore, for this particular problem, option A and option D are the correct choices. So A and D are the right choice. So therefore, for this particular problem, we have two options correct. And that's it. Hope you understood the problem. Thank you.